All right, so these three problems, actually the next six problems, are all going to be using elimination. So on elimination, what we do is we try to get two of the coefficients, the numbers in front of the variables, to be the same so that we can add the equations together and one of the variables go away or are eliminated, hence the name elimination. So if you look at this equation, this first equation right here, we see that there's a 2 in front of the y on both equations. However, they're both negatives. So if I were to add these two equations together, it would not eliminate the y's. It would actually just give me a negative 4y. So I'm going to multiply this bottom equation by a negative 1. And what that does is it gives me a negative 4x and a positive 2x, or 2y, sorry, equals a negative 18. That way, when I add this equation and this equation together, the 2's cancel. So 6x plus a negative 4x is a positive 2x. Negative 2y plus a positive 2y is 0. So the y's are gone now. Okay. And then 32 and a negative 18 gives us 14. Positive 14. So if I divide by 2, we get x equals 7. So now we're going to kind of use a little bit of substitution here. Since we know that x is 7, I can pick any of these two equations that we've used so far, either one of these two equations, and actually any three of the equations, and plug that x equals 7 in for x. So if I use this equation right here, this 4x minus 2y, 4x minus 2y equals 18. If I use that and plug x is 7 in right there, we can solve for y. So 4 times 7 minus 2y equals 18, all right, which is 28 minus 2y equals 18. We subtract 28 from both sides, and negative 2y equals negative 10. If we divide by negative 2, we get y equals 5. So now we have x is 7 and y is 5. So our ordered pair is 7, 5. All right. All right, let me clear this here so we can go on to the next one. So if you look at this one, they were super nice, and you have a negative 5y and a positive 5y. So all we have to do on these two is combine the two equations, because 2x plus 4x is 6x, but negative 5y plus a positive 5y is 0. So that's gone. So the y's are gone. And then negative 28 plus 4 is a negative 24. We divide by 6, and we get x equals negative 4. So now we take our negative 4, and we plug it back into either one of these equations. So I'm going to just do the 2x one here. So 2, and then instead of x, I'm going to put negative 4 because we know that's what it equals now. Minus 5y equals negative 28, which is negative 8 equals, whoops, not equals. Let's back that up. Negative 8 minus 5y equals negative 28. So I add 8 to both sides, and that leaves us a negative 5y equals negative 20. Divide by negative 5, and we get y is 4, because it's a negative divided by a negative, so it's a positive 4. So now we have negative 4, positive 4 is our ordered pair for number 12. All right, 13 real quick. On this one, I can either multiply this top equation by 5 and get, or a negative 5, and get negative 5x on top and a positive 5x on bottom. Or I can multiply the top by a 2, which would probably be the easiest. So I'm going to do that, and it gives me 2x minus 2y equals negative 18. So that when I combine these together, I get 7x equals 14. Divide by 7, and x is 2. So if I plug 2 back in for x right there, I get 2 plus y equals negative 9. Subtract 2 from both sides, and y equals negative 11. So your ordered pair is 2, negative 11. All right.